Hey everyone! So, before a programmer even thinks about writing code, they need a plan, a blueprint. And today, we're going to break down the two most important tools they use to build it: algorithms and flowcharts. Okay, let's just think about this for a second. How do you actually tell a computer what to do? See, the thing is, computers aren't smart. They're just really obedient. They need you to give them incredibly precise, step-by-step instructions for, well, absolutely everything. And that precision, that perfect set of instructions, it doesn't just, pop into your head when you sit down to type. Nope. Before a programmer writes even a single line of code, they need a solid blueprint. It really does all start with a plan. We're calling this whole process the programmer's blueprint. It's really just the structured way you get from having a fuzzy idea of a problem in your head to a real working program on the screen. You can really break down any programming task into two big phases. First, you've got the problem-solving phase. That's where you create the plan. Then you have the implementation phase, which is when you actually write the code. A lot of people think programming is just the coding part, but for this, we're going to focus entirely on that first part, because honestly, the plan is everything. All right, so let's get into our first planning tool. The absolute best way to think about an algorithm is like a recipe. It's the whole plan for your program, just written out in clear, logical words. At its core, that's all an algorithm is. It's just an ordered sequence of steps that solves a specific problem. That's it. It's not magic. It's not some crazy complicated math thing. It's just a to-do list, a really clear one. But here's the thing. You don't just jump straight into super rigid computer speak. A lot of the time, programmers will start with something called pseudocode. It's basically an informal way of writing things out that's super close to just plain English. Think of it like a rough draft of your recipe. And this shows that process perfectly. Over on the left, you've got the pseudocode. It's a simple idea, right? Calculate their average. If it's below 50, print fail. It's easy to understand. Then, on the right, you see how that same idea gets refined into a detailed algorithm. The steps are numbered, you've got variables. It's much more structured, much closer to something a computer can work with. Okay, so we've got our recipe written down in words. But what if you could actually see the logic? What if you could see the flow? Well, that takes us from the recipe to our next tool, the map. We're talking about flowcharts. A flowchart is exactly what it sounds like. It's a diagram, a visual representation of your algorithm. It takes all those steps you wrote out and turns them into a map, using different shapes for different actions, and then connecting them all with arrows to show you which way to go. And to build these maps, you've got a pretty simple toolbox of shapes. The oval, that's your start or your end. The parallelogram is for any time you're getting data in or sending it out, so input or output. The rectangle is for a process, like doing a calculation. And then there's the most powerful one of all, the diamond. That's for making a decision. All right, so theory's one thing, but let's actually put this stuff to work. We're going to tackle a problem that isn't just a straight line. It's one where the program actually has to make some choices. So here's our challenge. It's a classic programming puzzle. Find the largest of three different numbers. Now, for us, that sounds easy, but how do you write down the exact instructions so a computer can solve it perfectly every single time? First, we make our recipe, the algorithm. Step 1, we get our three numbers. Let's call them A, B, and C. And then step 2 is where the real thinking starts. We have to use if statements to compare them. We ask, is A bigger than B? And depending on that answer, we then have to check against C. We follow that logic all the way down until we know for sure which one is the largest. Okay, recipe's done. Now let's build that visual map. And every single flowchart, I don't care how simple or how complicated it is, always begins the exact same way, with a start oval. From there, we just follow our recipe. The first action is to get our data, right? So we use a parallelogram to show that input step, read A, B, and C. Simple enough. And now we get to the really powerful part. The program has to make its very first choice, and we show that with a decision diamond. It asks a simple, direct yes or no question. Is A greater than good? And right there, depending on whether the answer is true or false, the map literally splits. The flow branches and goes down a completely different path to the next logical question. And that right there, that is the power of a good flowchart. You can visually trace every single possibility and see with your own eyes that no matter which numbers you start with, every path eventually leads to one final correct answer. There are no dead ends. The logic works. So you might be thinking, okay, why all this work? Why are we drawing all of these boxes and arrows before we even write one line of code? Why does this planning stage matter so much? Well, it's pretty simple, really. These blueprints let you see your own thinking. You can spot a flaw or a mistake in your logic way before you've wasted hours coding it. And they create this universal language. It makes it so much easier to explain your program's logic to somebody else. This way of thinking, breaking a process down into steps and decisions, it goes way beyond just programming. So I'll just leave you with this thought. What's a daily routine you have? Like making breakfast or deciding what to wear, that you could map out with a flowchart. Think about it.